Imagine a world where a simple cut on your finger or a routine surgical procedure could potentially be fatal. This was the reality before the discovery of antibiotics. Miraculous drugs that have saved millions of lives by effectively treating bacterial infections. This invention saved lives, however, created additional issues also. To know more about these miraculous drugs, Amiris Biotech dedicated these informative video for all its followers. Let's understand it better that have saved millions of lives by effectively treating bacterial infections. The very success of these drugs has given rise to a formidable challenge known as antibiotic resistance. This phenomenon is reinstating old threats and creating global health crises, jeopardizing the advances made in modern medicine. Antibiotics are chemical agents specifically designed to combat bacterial infections, either by killing bacteria or inhibiting their growth. They target the unique features of bacterial cells without damaging human cells, offering a targeted approach to disease management. For instance, penicillin, the first antibiotic discovered by Alexander Fleming in 1928, disrupts the formation of peptidoglycan, a key component of bacterial cell walls, leading to the bacterium's demise. As antibiotics wage war against bacteria, they selectively target processes like protein synthesis, DNA replication, and cell wall formation. Drugs such as tetracycline interfere with bacterial protein synthesis, while fluoroquinolones disrupt DNA processes, curtailing the bacteria's ability to multiply and spread. This specificity underscores the remarkable power of antibiotics to target infections without significant harm to the host organism. This delicate interplay between antibiotics and bacteria is, however, shadowed by the relentless evolution of bacterial populations. Through natural selection, bacteria that randomly mutate and develop resistance to these drugs can survive and proliferate. This survival advantage is exacerbated by the misuse and overuse of antibiotics, which provides favorable conditions for resistant strains to dominate, setting the stage for the next part of our discussion. Antibiotic resistance emerges when bacteria evolve mechanisms to thwart the actions of antibiotics, turning standard treatments ineffective and allowing infections to persist and spread. This resistance can develop through genetic mutations or by acquiring resistance genes from other bacteria, a process that can be facilitated through simple mechanisms like conjugation. Bacterial resistance is not just a theoretical concern, it has palpable and devastating effects on global health. For instance, methicillin-resistant Staphylococcus aureus, or MRSA infection, once primarily restricted to hospitals, is now found in community settings, complicating seemingly minor infections. Moreover, the World Health Organization, or WHO, cites antibiotic resistance as one of the biggest threats to global health, highlighting cases where treatments for prevalent diseases like tuberculosis and gonorrhea are becoming increasingly ineffective. To combat this growing threat, global health initiatives are increasingly focusing on antimicrobial stewardship programs which aim to optimize the use of antibiotics among healthcare providers. Research is also underway for novel antibiotics and alternative therapies like bacteriophages and antimicrobial peptides. Further real-world application is seen in initiatives like the UK's subscription-style payment model for antibiotics, aimed at encouraging pharmaceutical companies to develop new drugs without the pressure of marketing for widespread use. As we continue to wield antibiotics against bacterial infections, it becomes imperative to use these powerful tools judiciously and foster innovations that can circumvent or overcome resistance. The success of this endeavor will not only dictate the future trajectory of infectious disease management, but also safeguard the legacy of antibiotics as one of the most significant medical breakthroughs. This exploration of antibiotics and the looming peril of antibiotic resistance sheds light on the intersection of human ingenuity and natural selection. By understanding and addressing this complex challenge, we can preserve the efficacy of antibiotics and ensure that these lifesavers continue to protect countless lives in the era of modern medicine. Thus, this delicate balance of use and preservation requires our immediate and unwavering attention. We in Amiris Biotech dedicated to propagate rational uses of antibiotics and participate in various antibiotic stewardship programs. Thanks for watching, and thanks for your support.